Okay, so Earth has 4 layers. We have the crust, the mantle, the outer core, and the inner core. Well, some people compare the Earth to a chocolate-covered cherry. And I like this because this is really a mature taste. Young kids really cannot appreciate how delicious a chocolate-covered cherry can be. The outside is a crust of solidified chocolate. The inside you have a plastic-like chocolate. And then inside there you have the liquid from the cherry, and then of course in the very center is the cherry itself, which is extremely hot. Now on a chocolate-covered cherry it wouldn't be hot, but the red signifies very, very hot. Now inferences can be made of Earth's interior by studying seismic waves. For example, we can determine how dense the material is at each layer. We can also determine whether or not they're solid or liquid. This is why we think the outer core is liquid, is because of the seismic waves. And if we know the density and whether it's solid or liquid, we can determine or infer other things. For example, composition and also the pressure. Okay, so let's talk about Earth's layers. The crust is the outermost layer of the lithosphere. Oceanic crust is crust underneath ocean water. It's made up of basalt. That's an igneous rock. You should be familiar with it. And it's about 5 miles thick. Now, continental crust, that's a different matter altogether. That's the crust that makes up the continents of the Earth, the ground that we are standing on. It's made up of granite. It's also an igneous rock. You should be familiar with that. It's about 35 miles thick. So this gives you a little picture. You can see how much thicker the continental crust is, how much thinner the ocean crust is, and that's why the ocean sits on top of it, because the ocean crust sits lower into the Earth. When the Earth was originally all liquid, the densest materials will settle into the middle, and the lighter materials will float to the surface. This is why the core is composed of the densest materials like iron and nickel, and the lightest materials like quartz floated to the surface and made granite. Okay, so this is your reference table, page 10, and you can see how it shows you the different layers of the Earth, and on the right it tells you their density. So for example, we can see that the density of the continental crust is 2.7 grams per cubic centimeter. The density of the inner core is about 12.7 to 13 grams per cubic centimeter. So what we learn is that within the Earth, as you go deeper and deeper, temperature will increase, pressure will increase, and density will also increase. Evidence for crustal movement can be seen by tilting, folding, and faulting. Tilted rock layers are where layers of the Earth are uplifted on one side. Okay, so this is a nice picture of an outcrop where you can see that one of the rock layers is tilted on top of the other rock layer, which is flatter. So here's a nice picture. You can see the rock layers have been cut, and I've drawn these little yellow lines to show you where those faults are. And each of those represents a fault that represents the Earth's movement. And again, faults are evidence that the Earth is moving. Well, this is a very important map. Take a look at it very carefully. The little red dots represent earthquakes. And as you can see, earthquakes don't occur evenly across the Earth. They're in very specific little lines, or what we call belts, earthquake belts. And this is a very critical piece of information. Why would earthquakes be located where they are? If you can answer that, I'd be very interested to know what your answer is. And we will be doing a lab to demonstrate this. This turned out to be a major piece of evidence for a new theory on what's happening with the Earth. So I want you to just look at this. Earthquakes occur in a very specific locations around the Earth. And as you can see, some places get lots of earthquakes, which is why they're so red, and other places don't get any earthquakes. Once you understand why earthquakes are where they are, then you can determine what the likelihood is that an earthquake will strike. And as you can see in New York here, we really have a minor risk of earthquakes in New York City. Moderate risk would be in upstate New York, which is not where we live. We live in downstate by the city. What are earthquakes? Any movement of the Earth's crust, and it occurs when stress and pressure build up in the Earth and are suddenly released. Which brings us to the obvious question, what causes stress and pressure to build up on the Earth? And the theory is that there are convection cells within the mantle that are pushing the plates to move. So what is a fault? A fault is a break or a fracture in the rock where motion occurs, and is found both below the Earth's surface and also at the surface. Okay, so a normal fault is where the rock is separating apart, and so one side slides down. A thrust fault is where the rock is being pushed together, and so one rock is pushed over the top of the other. And a strike-slip fault means the two rocks are moving past each other, but are not moving away or towards each other. So what is the focus of an earthquake? The focus is the point beneath the surface of the Earth where the earthquake originates. A seismograph is a device that records earthquake waves.